Okay? When we get into talking about all of this probability that we're doing, we've moved a little away from the permutation combination stuff that we were doing before and moved more now towards straight, honest to goodness probability and odds of things. So just a couple of reminders. Probability is your number of successes, or what you want or to occur to happen over the total number. Odds, on the other hand, is slightly different. It's still the number of successes, or what you're being asked to find, except instead of being over the total, it's over the number of failures. So basically you do success total minus successes, and you get the failures for your odds. That's one difference that some of you are starting to notice. Here's the other one, and it's a very small difference. The difference between the word then or and when the word or is involved with something. If there's just a comma, okay, this is the equivalent of having the word then in there. So if I were to write this out, what I'd be asking is, what's the probability of drawing a black card, then drawing a red spade? Those are two separate events that are going on, but I have to multiply their probabilities together to get to the answer. So like, for instance, if this were the problem that we're actually doing, my odds of drawing a black card would be 1 out of 2, because half the cards are black. But then, what's my probability of getting a red spade? Somebody's got to know their cards out there.
13 divided by 2.
No, a red spade. Think.
That's
0.
Zero.
There are no red spades. They're black. So, times 0 means there's no chance of you drawing a black card and then a red spade, because there's no such thing as a red spade. Okay. Now, what if I change one little word in the middle? Probability of a red card or a 9. That changes what I do. Now I've got to add the individual probabilities, because maybe I get a red card but I don't get a 9. Or maybe I get a 9 but I don't get a red card. They're not dependent on each other. So in this case, what I would do is I'd say, okay, my chances of getting a red card, well, there's 26 of them out of 52. And you're like, why aren't you reducing right away? There's a good reason. What's my chances of getting a 9? How many of those are in a deck?
A lot.
4. So plus 4 out of 52. But then any overlap. So are there any red 9s?
1,
2.
9.
So 26 plus 4 is 30. Minus 2 would be 28 over 52. And then again, you'd go and you'd reduce that down to its simplest form. Okay? Little detail words are what make or break you on probability and or odds. Okay? So I just want you to have that available to think about as you're working through some of these. Just in case, there's parts you haven't started yet. Okay? So, now that we chatted about that a little bit, are there any on there, again, that you've attempted, gotten a different answer, and would like maybe to discuss a little bit? And to help some of you that are trying to think ahead, when's the next quiz, when's the next test, the only thing in the probability is going to be a test. It will be a week from Tuesday.
Why so far out?
Because we still have 2 more sections. I know how we get when I try to do a section in a day, and then I also want to have a review. And I do not like Monday tests.
Still not.
What do we do after probability?
After probability, we will be doing statistics.
How many more tests or units are we going through?
Get this looking a little bit more normal. There we go. Okay. 11, if I am on the right one here, with more probability and counting, says, what is the probability now? This is going to be, okay, because I know what the question is going to be. It says above, multiple events, coin toss, and number cube. However, there is nothing mentioned of a number cube. It's 2 coin tosses. So now, depends on how you read into it, because I wasn't reading into it on how I have a feeling you may be. I just read into it as, oh, it's 1 out of 2 are getting a tail, 1 out of 2 are getting a tail, it's 1/4. But now that I look at it, right up above, it says that it's a coin toss and a number cube, multiple events. Now, if that's true, that would be assuming that one event was a coin toss and one event was a number cube. Well, if I do tail, tail, I have 0 number cube events, so that doesn't work. So I would assume here, I guess, I need to read a little more carefully, that you could assume, I'm assuming you say it's 0. And I can absolutely see how you do that, and I'm actually going to agree with you on that. Because here, one needs to be a number cube event, which we, number cube event, which we do not have. So in this case, the probability of tail, tail occurring with the circumstances would be 0. I agree. I agree wholeheartedly. That was an excellent catch.
Feel bad. Feel bad.
I got a lot.
Any other specific ones? 3 on the same one?
Yeah.
Okay, I knew it would come up. I should have my experts on number 3
Maybe.
come up and do this. A couple of us did this one before school too. Okay, we have a deck of cards, and I'm looking for the probability of drawing a jack, then drawing a queen. Now the word then isn't put in there, but we assume it with the comma. So let's think about this for a minute. Okay, my probability of getting a jack, there's 4 jacks in the deck out of 52, but, right, if it's a jack, then a queen, once I pull the jack, that card's gone. How many cards do I have left? I only have 51 cards, but all 4 queens are still there. So that's the trick here. And again, it's the symbolism and the words that we've got to get used to. So then when I multiply it across, I get a monstrously large number, which is going to reduce down. But that's where...
You should put that on the test like that.
But again, and people had mentioned this yesterday, it's good to get you into the practice of, we discuss what it means, but to actually have you on quizzes and tests, see it in the language that you would see on a standardized test or something, so you're used to it. Because that's one of the things that tends to get to students the most, is they're like, well, I didn't understand what the question was saying. So if we explain it, but also show you the format that it probably would be in a book or on a test, probably a good idea to keep it this way. So I'll keep barking that comma is really then, but I just won't.
So we should be able to remember that.
So if it's and or, do you multiply it?
If it's and, then kind of goes along with and. If it's and or then, you multiply. If it's or, it's adding. And then you're going to subtract any overlap that you have.
Oh.
Yes, ma'am. Yeah, uh-huh. All right, 15 on the same sheet here with more probability and counting. We're looking for odds now. So that changes things a little. So draw a heart or a 10. Okay. So there's our or again. So we know what we're going to take, drawing a heart, add that to drawing a 10, and then subtract any overlap that we have. So let's see here. How many hearts are there in a deck?
13.
13. Okay. Did I do something? Well, we'll see. I think I may have done something boneheaded since I don't see my work here, but we're going to find out. Okay, so there's 13. So now, how many 10s are there? 4. How many 10s that are at a heart are there? 1. So let's see. I copied the wrong one. 13 plus 4 is 17, minus 1. Now here's the part I'm going to do right now. There's 16 successes. There's 52 total outcomes. But again, we're not doing probability. This would be my probability after I reduced it. But I want odds. So I have 16 successes. How many failures do I have then? 52 total, 16 successes, 36. And I did copy the wrong one over there. Because if I reduce this down, 8 over 18 would be 4 to 9 once I reduce. That's what I did. I copied the wrong one. When, for instance, you're doing this one, because remember, odds is success or failure. So one way I could have looked at this, if I wanted to look at it a little bit differently, because maybe looking at the fraction makes me think it's probability instead, I could sit here and say, okay, hearts, there's 13. 10s, there's 4 of them. But then I got to subtract the 10 of hearts, and there's 1 of those. So 13 plus 4 is 17, minus 1 is 16. But then I know there's 52 cards in the deck. So if 16 are successes, 52 minus 16 means there's going to be 36 failures, and that's where it's coming from. Or it may be that we're used to seeing it drawn in that format instead.
But we do like use the denominator always have to be the same, or would you ever subtract it or
With odds, it's not going to make as much of a difference because once I get this set, I'm going to be looking for failures instead of a total on this. So like if I had to reduce this at the start and called this 1/4 and 1/13, that actually would have caused me a problem here because I'm not looking for the probability where I'm going to find a common denominator, which I'd have ended up back at 52 anyway. So when you're doing probability or odds, normally I'm of the opinion that I would not reduce fractions necessarily right away until the very end because it may come in handy with you finding a common denominator anyway if you need one.
well, I mean, like starting off like with those 13
Oh, I see what you're saying. You could do the odds for each individual part, but that's going to get complex because you're going to have different denominators for every one of these, and then you're going to have to go find a common denominator to bring it back. So if you're doing odds, it's easier to just deal with the individual pieces and do it in probability, or just even like this, just count your successes as you're working with those. We are going to run the same concept that we were on number 15 if we go back to number 5. So if we bump up a bit here, we're looking for the probability of a red card or a 10. Okay, so there's OR, which tells me I'm going to be adding these probabilities together and then subtracting any overlap that we have. So this is where I would leave my fractions whole until the end. So red cards, how many red cards are in a deck? 26. Okay, so 26 out of 52. Notice I'm not reducing yet. I'll do that at the end. Plus, how many 10s are in the deck? 4. But then I have to subtract the number of red 10s, because that would be my overlap, 2. So 26 plus 4 is 30, minus 2 is 28 over 52, but then I can reduce that down. This is my probability. That's my answer for this one. But for some of you that are still getting this whole probability and odds thing confused, okay, if I wanted odds on this right away, it wouldn't be hard to figure out. Because remember, when I do probability, it's my number of successes over the total number of options there are. If I wanted to do odds for the same thing, 28 would be my successes. If there's 52 total and 28 successes, how many failures would there be? Because success and failure always has to add up to everything. Everybody's like, I am busy working on my homework. Don't ask me these things until I want it again in a minute. 52 total, 28 successes. How many failures? 24. Thank you.
Did we already do 17?
We can. And then again, once I get to here, I could reduce this down. So if I did 4 in each of those, it'd be 7 to 6 would be my odds. It's different than probability, but I can use the same information to get either. And that's kind of the point that I'm just trying to get across here with these, that you can do that. Now, when this gets a little more interesting, when we move down to one like 17, okay, it says the probability of an event happening is 3 out of 12. Now, what does that tell me? Well, it tells me 3 bits of information. It tells me I have 3 successes. It tells me I have 12 total outcomes because it's probability, which gives me 1 bit of information I don't see. I have 9 failures. So, what I'm being asked is, what are the odds of this event not happening? Okay, now, my successes just changed. Before, my successes were this occurring. Now it's not occurring. So I'm going to explain 2 ways you could tackle this, and you'll kind of have to figure out which way you want to do this. I could either look at this and say, okay, well, if the probability of it happening is 3 out of 12, the probability of it not happening would be 9 out of 12, because it'd be the rest of them. If you did it that way, you could say, okay, the odds of it not happening, my successes would be 9. My failures, if I have 9 successes, I have 3 failures, and then I could reduce it. Okay? That's one way I could look at it. That's normally the way I personally look at it. Because otherwise I'm looking at it going, well, so these just flipped. And basically you'd say, if it's versus happening, now it's not happening, I could just reverse these and say, well, now I have 3 failures and 9 successes. And that's what I have here. But I always can get all of this information out of my probability fraction, or even my odds ratio if I wanted to. But you just got to be careful with the language, because they'll flip it from happening to not happening or not happening to happening, and you've got to be along with that. Again, good questions. Other issues? Yes, ma'am. 21. Move up a little more here. And just in case people are looking at this later on this, here's the sheet that we are working on right now. From Monday, more probability and counting principle. All right. 21. An access code must be in the form of 3 letters followed by 4 digits. However, the first letter cannot be O, and the letters cannot be repeated. How many different codes can we make? Okay. So we've got 3 letters and 4 digits, or 4 numbers. So I like being able to visually see, okay, what I'm getting myself into here. So let's see what the restrictions are. The first letter cannot be O, okay? So I now have 25 options for my first letter. Now let's see if there's anything else. And the letters cannot be repeated. Now this is the tricky one. Whatever letter I used for the first one, let's say A. Okay, I can't use that anymore. But can I use the O now? Yeah. So how many choices do I have? I still have 25. Okay? Because here, let's say I used the letter A. Okay? I can't use A here. But I can use O now. So I lost one, but I gained one back. Okay? But now here, let's say I use, I don't know, let's get real creative here, B. How many letters do I have left to use in my next one? 24. Because now A and B have been eliminated. But I can use any of the rest of them. But then at least they lay off of us a little bit. Are there any restrictions on the digits? I don't see any. So I could use 4 different digits. I could use the same digit 4 times. So how many choices do I have for each of my numbers? 10. And that's where the answer would come from. That really, really, really big number. Yeah, I know this unit's called like probability, but it could actually be called critical thinking and be just as properly titled. But yeah, when in doubt, draw it out. I'll steal that from a Bruzo. Cross it out. Oh no. Sure. Okay. All right. So now let's switch over. We're going to switch to the other sheet. We're going to switch over to probability and odds here. On 18, I'm going to So here, for instance, in case you had missed, we are now moving over to the probability and odds sheet back from Friday, last Friday that is. And we're looking at 18A, did you say?
Yeah.
Okay.
All of them, like, I'm getting 207 instead of 205.
Yeah, I got 207.
What are you?
All right, let's see what's up here. Let's take a peek at 18. So we got males and females enrolled at Oak Grove High School, as given in the table below. We're conducting a survey on reading habits for the school newspaper by selecting students at random. Okay, here's something I usually do when I get a chart like this. I know sooner or later they're going to ask me about males or females or one of the individual grades. So what I normally do is I go through and I go ahead and total up, in this case, my males. Let's see here, 150, 250, 4 1/4, 535. All right. So what's the probability that a student chosen is female? And I think I see, let's see. So females, we got 535. And we would have 1,035 total. So let's see what we reduce down to here.
107.
What? Let's see if this continues. I think it does. Let's check this out. What's the probability that a student chosen is a male in the 9th grade? All right, let's see. Male in the 9th grade over the total. Let's see if some of you start looking like geniuses here. Everybody comfy with answers so far? They're like, I don't know, we're busy scribbling. Talk to us later. Okay. What are the odds that a student chosen is in the 10th grade? Now, careful. It's odds now. So 10th grade, I have 250 10th graders. That's my successes. Don't put it over 1035. Yep. Because if you take your total minus your successes, I'd have 785 failures. And again, that's the difference with when we're playing with odds versus when we're playing with probability. So 50 to 157. And let's just make sure on the last one too, because like we said, it changes everything. If a student from the 11th grade is selected, is it more likely that the student is male or female? Okay, yeah, I was going to say this one, it's hard to screw up. Because we can just look and say, well, there's more females, so yeah, that's more likely. Didn't ask me for a number, so I won't give them one. All right, let's flip over here.
Or do one of those, I'll try to figure it.
Perfect. All right. So let's see here. Anybody with preference? Since 11 through 13 have been requested, and I like the idea of doing one of them. Now, again, it's going to be different. 11 and 12 are odds. 13 is probability with the magic word "or" in the middle. So you're going to be adding the probabilities of each and then subtracting. But now, let's say we go up to number 11. What are the odds of selecting a club? Okay, so let's see. So we're looking for success over failure. How many clubs are in a deck? Okay, let's back up. 13, okay. I was going to say, otherwise we'll say how many suits there are. Now again, it's not over total, so it's not over 52. 39. Because again, my successes and failures always have to add up to the total number of cards that are in the deck. So at this point, I'm just taking that and I'm going to reduce it as far as I can, but 13 divide into each of these. So my odds of selecting a club would be 1 to 3. There'd be one success for every 3 failures, which makes sense because my success would be clubs and my failures would be hearts, diamonds, spades, 3 of them. So that's the outlook that we would use with that one. Any other issues that we are running into with our probability and odds? What's that?
What's a club?
It's one of the 4 suits. Club is one of the 4 suits.
I don't know if it's like
Do I need to put something on the video with like cards and suits? Yeah, okay. Okay, a general help here. Okay, when you're looking at a deck of cards, you have 52 cards, okay? You have 4 suits. So there's hearts, there's clubs, there's diamonds, and there's spades. And there's 13 each of those. And then you'd have individual cards. So like your ace through king, but there's one of 4. So there's 4 each of those, one of each suit. And then there is 26 red and 26 black, because your hearts and diamonds are red and your clubs and spades are black. I think they're going to get to a point on things like this that they'd be able to put odds better of putting things like what's the odds of getting a certain color, like Candy Crush or something, than there is in playing with cards anymore. Okay, so if we do something then with probability, I'm going to yank this for now. Okay, probability of selecting a club. Okay, there's 13 clubs out of 52 cards. Okay, there are 4 aces out of 52 cards. How many cards in the deck, though, are both a club and an ace? 1. There's 1 ace of clubs. So then, and again, I'm doing probability, so I have to keep my denominator here because it'd be my total. 13 plus 4 is 17, minus 1 is 16 over 52, but then again, I need to reduce my fraction down. Yeah, it's all about little words, whether it's probability or odds or if there's an or in the middle.
Ones with what are for number 18 on more probability.